We might not be able to 3D print a lava lamp, but how close can we get to the lava lamp experience with just 3D printing and simple electronics?
Hi everyone, I'm Rob. I recently got interested in kinetic sculptures and I want to build some of my own. I want something glowing, something moving, something I can leave with me in a room for hours and forget about it. And then every time I look at it, there's something new to see. Sort of like a lava lamp. This slow motion with the glow. This is exactly what I'm aiming for. And I want to get there mostly through 3D printing, some simple electronics, motors, lights, and so on. And for the first project, I want to build an animated spring inspired by this.
The idea behind this kinetic sculpture comes from this model I made a while back. This is a simple spring that uses steel wire ropes and provides some compliance. And I want to somehow combine it with this geometry, so the idea is to have a motor in the base, vertical shaft going up, some wobbling discs around the shaft, and a helix going through the discs up.
But first I need to decide which motor to use. I've seen a bunch of people use these cheap yellow DC motors, but they're very noisy and I need something that I can barely hear. So I'm gonna test a bunch of motors and see which one is the most quiet, but I'm gonna keep this one in the comparison just to see how much quieter can we get.
These are the motors I have right now. These are common hobby DC motors and servos, and since I want this thing to be quiet, I will test all of them with a noise meter. I tested them all at a distance of 1 meter and then at 10 centimeters on different voltages and surfaces.
We can see that the S30K motor is the clear winner here, closely followed by the worm gear motor. Looking at the no-load current, we can also see that the S30K motor is really efficient, making it great for battery-powered devices. But I'm not sure if it's going to have enough torque for this project, so I'm going to go with the slightly more noisier worm gear motor and see if that's okay.
Oh yeah, and these are the servo motor measurements. They were basically too loud for me to use. I decided to use FreeCAD for this model, and even though it can be frustrating at times, I'm still amazed that this software is completely free. The main star of this kinetic piece is the disc, which will wobble like that. It has a place in the middle for the bearing, and then we have holes around the rim for the helices. I did a few iterations on it, making it simpler and more minimalistic, and ended up with a version where the bearing is held by this retainer that clicks into place so that the bearing is held from both sides. I'm using a lighter here to help me fit the printed part onto the motor shaft to get a tight fit. Next, I have an M3 threaded rod, which screws into the motor shaft and holds all of the shaft segments. These segments are slid onto the rod and interlocked like this, so this is where the bearing will sit. In theory, I could put as many discs as I want on the shaft, but to test it out I will use just 3. The last disc is horizontal and is being held by this small part with an M3 nut that can be tightened with a wrench. Here I connect it to 6 volts and we get this wobbling movement. This is exactly what I wanted to see. And now for the actual star of the show, the helix. I'm waiting for the light guides to be delivered, so I'm just gonna use some PLA for now. I have the filament pieces and the assembly so far. Now it's time to thread the wire through the holes. The PLA was clearly too rigid for this application, and I was hoping the light guides will be a lot more flexible. I've tried to run it with 2 helices in place, and I've noticed that it makes this a lot of clicking sounds, and it was also jumping around quite a bit, so obviously the PLA was too stiff, and I've also noticed that it's moving through the discs. So I made some markings, and yes, that confirmed that it is actually moving through the discs. So I decided for a bit of a redesign. It is a few days later and the light guides have arrived, and luckily they're pretty flexible. I also have this older one that I have from a different project, but this one is really stiff. I've also redesigned the discs, so now instead of going through the disc in like a helical shape, it actually just goes through these holes around the perimeter of the disc. And that way, I think we're also gonna get more flex between the discs, because now it's gonna be able to flex. So it was assembly time again, and this time I used more discs and made the whole piece taller. The flexibility of the light guides really helps here. Alright, first test with the light. So I have just a 5mm LED here in the center hub. So that was a promising result, but let's see how it looked like with 6 light guides. Yeah, here it starts to look a bit messy. I made a mistake and put the pattern of 8 holes to the bottom part, so the light guides were all misaligned, and I think that creates the unorganized look. Nevertheless, I did try to run it just to see if the motor can handle it, and yeah, it could. And the movement looks pretty good. I printed the center hub again, this time from wood fill filament and with the correct amount of LED places. Next, I'm using these orange LEDs, this USB power delivery module set to 9 volts, and I will use a small step-down module for the LEDs. The discs are basically the same as before, I've just added these capped ends on the top disc. The assembly stays pretty much the same, however this time I made some markings to help me thread the light guides evenly. All the light guides are installed and we're ready for some testing. As the discs wobble, the individual helix segments contract and extend, creating this interesting movement. But you can also see the discs rotating a little bit in this jumpy movement, and that kind of breaks the fluidity. The shaft is not constrained at the top and it bends a little, so the whole sculpture moves around a little bit. I think for some next kinetic sculpture I will create more rigid frame to constrain the movement and create a more defined motion.
So this is running on 9 volts. Let's measure the sound. So I have around 54-55 decibels. It's still pretty loud. I'm aiming for something between 36 and 40, so I'm not sure if I'm going to be able to get that with this one. On 9 volts the motor itself is not that loud, but the whole structure seems to be amplifying it quite a bit. I'm going to try it on 5 volts and lower and see if we get lower sound but still the same speed of motion. 46, so that's not that bad, but I'm aiming for sub 40. The movement doesn't seem to be too affected by the lower voltage, so I will see what happens if I lower the voltage even further. This is still on 5 volts, but I've noticed that a lot of the sound was transmitted through the wooden table below it, so I've added some paddings and check this out. I'm getting around 40-41 right now, so that's a lesson for next time. I really need to think a lot more about sound isolation and vibrations. I'm running it at 3.5 volts right now, which I think is about as low as I can go without it basically stopping. And I'm getting around 39 decibels, but there's still some creaking in the sound.
I would like to take a look back and rate this piece as feedback to myself and to see what others think. There are 3 requirements that I like and care about in kinetic sculptures. I'm calling them depth, flow, and silence. Depth is how interesting the piece is, flow expresses how smooth the movement is, and silence is self-explanatory. I would rate this piece 3 out of 5 on depth, 1 on flow because of the jumpy movement, and 2 on silence.
So that's it for this kinetic sculpture. See you in the next one, and keep building cool stuff.